So next in this polynomial modeling lesson, we're going to look at surface area type problems, surface area of boxes specifically. So in number 6, a manufacturing company is requesting engineers to create a square box with a volume of 175 cubic centimeters. In order to keep the cost down, they need to design the box so that they have minimum or minimized the amount of material needed to construct the box. And so I should say this is a square base box because we don't actually know what the height of that is. So with this, I gave you a picture, but we want to create a model for the surface area. And if I think about this in general, we have a surface area formula that you could memorize, though honestly we just need to know how do we get the area of each surface. So I think about the area of this base would be a times a, so a squared, but there are two of those sides, so there's a front and a back. That would be two of these, so I'd say 2 of the a squareds. Then we have a side here that we can find the area of. So that area would have a length of h and a height of a. So if I find the area of that rectangle, it's AH. And there are 2 that are also that same size. Really, there are 4 if I include the top and bottom there, because all of the sides around the box are AH. So 4 of those AHs. Now that's a surface area equation that has A's and H, but we want to create an equation that is only in terms of the base length A. So we only care about A's, which means I need to replace that H somehow. So we're going to substitute in something for H, but that means we need some additional information, like when we were doing the perimeter and area equations earlier. So with this one, we know that the volume of this box has to be 175 cubic feet. Well, the volume would be A times H in this case. Length times width times height here is multiplying those 3 dimensions together. And if the volume is 175, that has to equal a squared times h. If I divide by a squared, I get h is equal to 175 over a squared. That is something that I can use to substitute in for h. So the surface area is 2a squared plus 4ah, and instead of h, we're writing 175 over a squared. Now that function could be simplified more, but I'm going to leave it with the way it is right now. If you did simplify it, the surface area would say 2a squared plus, and now we need to figure out what 4 times 175 is. So 700. The a over a squared, when we multiply those, a divided by a squared would leave me with just 1a in the denominator. So it would be plus 700 over a. So that would be our simplified form for that. So either one is okay, because in part B, all we care about is what is the expected surface area when the base is 5 inches wide. So if A was 5, the square base of this, the surface area would equal 2 times 5 squared plus 4 times 5 times 175 over 5 squared. And then we're just putting that in our calculator. Now you could use this one or the simplified one. Either one's okay. 2 times 5 squared plus 4 times 5 times 175 over 5 squared would be 190. So the expected surface area is 190, And when we think about the units that are happening here, these are being measured in feet. So the area is square foot. So the surface area is roughly 190 square feet. For number 7, we're creating a plexiglass box that holds 100 cubic inches. So that tells me the volume is 100 cubic inches. And it has a base that's 4 inches longer than it is wide. So in this case, I don't know what the actual box looks like, so I'm going to draw another box. We do know that the base is 4 inches longer than it is wide, so if x is the width of the box, then that length would be x plus 4. Unfortunately, we still don't know what the height of the box is, so I'm just going to let that be h, because it does not have to be the same size as the width. We can write an equation that's going to model the cost in this case, but the cost is how much it may cost to create the box, which is the surface area. All of these sides have an area that's being made from this plexiglass. So if I look at the cost of this, the cost of the whole box is $7.99 per square inch. So think about each side. This front side is x by h units. So, excuse me. I'm going to write this out in a way that might help organize this information a little bit. So front and back, it would be $7.99 times x times h. But there are two, front and back, so x times h's. Then we have some sides. So I'm going to look at the sides of this box. That would be x plus 4 by h. And there are two of those, so one here in the front and the back there. All right, that would mean it costs $7.99 for two of these x plus 4 times h's. And then there's a top and bottom here. It still costs $7.99 for each of those, so 2 times the top and bottom. This top here and bottom would be a length of x plus 4 and a width of x. So x times x plus 4. That equation is the actual cost equation. Now it's not simplified all the way, but it can be. If I wrote it out, I would have $7.99 times 2, which is $15.98. So we've got $15.98 xh plus, and then $15.98 x plus 4 times h plus $15.98 times x plus 4. The issue is we still have h in this equation. So look at where our h's are. We want to create a function where x is the width of the box, and that's our only input. C of x is the cost as a function of x. Right now we have a function of x and h, so we need to somehow substitute something in for h like we did in the previous ones. That's where this information about the volume comes into play. Because we know that the volume is 100, and that would be x times x plus 4 times h, we would divide by x times x plus 4, so h is equal to 100 over x times x plus 4. That can be substituted in for all of the h's in that equation. Now I am running out of space, so I'm just going to have to write this underneath, but c of x would equal 1598 x times, and instead of h, we're replacing it with 100 over x times x plus 4 plus 1598 times x plus 4 times h, and in place of h, we're writing 100 over x times x plus 4 plus 1598 x times x plus 4. Now this function is only x's. That can be simplified a little bit more for sake of space. I'm not going to do that right now. But in part B, we care about what is the box cost if the box is 6 inches wide. So x is the width. You're finding c of 6 and plugging that in. So I'd plug in 1598 times 6 times, and if you need to use the fraction button, use the fraction, but 100 over 6 times 6 plus 4 plus, and then we have that middle piece, 1598 plus 6 plus 4 times 100 over 6 times 6 plus 4 plus 1598 times 6 times 6 plus 4. The whole cost would be $1,151.25. This is a crazy expensive box here, but hopefully these are not realistic numbers. So there's our surface area. The general form is still creating your surface area equation and then substituting in information needed to make this only one variable.